of moles of carbon and say 0.0265 grams of pencil lead. Remember that we've got two conversion factors, and so if we want to go to moles of carbon and we want to start out with 0.0265 grams of carbon, we're going to use a conversion factor that cancels out grams, so we're going to say 1 mole of carbon over our 12.011 grams of carbon. Grams of carbon will cancel out, and that will give us 0.002206 moles of carbon. Of course, we're going to have to think about significant figures. There's 3 significant figures here, so that's 0.00221 moles of carbon. Okay, word about significant figures. I generally suggest using all of the digits that are available on the periodic table that you're using. If they give you 5 sig figs for carbon, you should use 5 sig figs for carbon. That way it won't limit your calculations. So this is 0.0221 moles of carbon. Moles, like any other units, you can use the prefix multipliers that we learned about in Unit 1. So 0.0221 moles of carbon, you can also say that's 2.21 millimoles of carbon. All right, so if we want to, actually we can also determine the number of atoms in a sample. So if we have a penny that weighs 3.10 grams, and if it's before around 1982, before they started making pennies out of copper and nickel, we could calculate the number of atoms within a penny. Okay, what we're going to do is now use both of those conversion factors for grams to moles and moles to atoms. So our final answer, we want atoms of carbon. So we are going to write that as our final units. Atoms of copper, So remember, we can have conversion factors with grams over moles, or moles over grams, and then of course atoms per mole, or vice versa. And of course we're going to need Avogadro's number here, so this is 6.022 times 10 to the 23rd atoms per mole. Okay, if we're going to start out with 3.10 grams of copper, okay, we're going to use the actually, the reverse of this, we're going to use a conversion factor that puts grams on the bottom so we can cancel out grams. 1 mole of copper. Look on our periodic table, and mine says 63.546 grams of copper. Grams is going to cancel out. And I know that in 1 mole of anything, including copper, I have 6.022 times 10 to the 23rd copper atoms. And that will give me, if you throw this in your calculator, and again, everything on bottom, you divide, everything on top, you multiply, and so that will give me 2.94 times 10 to the 22nd copper atoms. Okay, and so for this one, we were able to use the molar mass and Avogadro's number as a conversion factor. If we want to convert from grams to mass, or mass to moles, or moles to atoms for compounds, we actually have to calculate the molecular weight of the entire compound or molecule. Now these molar masses are sometimes called a couple of different things. Formula mass you often see, especially for ionic compounds, or even formula weight. Molecular weight is often used for molecules. All of these refer to the molar mass of compounds. Okay, and just like an atom, it's the mass of one in grams of 1 mole of molecules. So if you have 1 mole of water, you have 6.022 times 10 to the 23rd water molecules. How much do 6.022 times 10 to the 23rd molecules of water weigh in grams? Well, we have to first calculate the molar mass. And all we're going to do is apply a simple algorithm. We're going to figure out the number of atoms in the first element. So let's say that's 2 for height water. We're going to multiply it by its atomic mass for the first element. So that's 1.00789 grams per mole for hydrogen. And then, of course, 1 times for oxygen, 15.999 grams per mole. And that will give us around 18 grams per mole for water. Okay, let's do a couple more examples and actually do the calculations. Okay, so let's do the molecular mass, molar mass, molecular weight, formula weight, however you want to say it, for magnesium hydroxide. Okay, again, these are this is an ionic compound that contains a polyatomic ion, so we have parentheses. So remember that 2 gets distributed into both the oxygen and the hydrogen. So the molar mass for magnesium hydroxide would be 24.305 grams per mole plus 2 times 15.999 grams per mole plus 2, and that's for oxygen, and plus 2 times 1.00789 grams per mole for hydrogen. And that gives us a total of 58.319 grams per mole, and that is the molar mass of magnesium hydroxide. Okay, so let's calculate the molar mass for glucose, C6H12O6. Okay, we don't have any polyatomic ions here, so we don't have to worry about distribution. So it just clearly shows that there's 6 carbon atoms, so we're going to add 6 times 12.011 grams per mole plus 12 times 1.00789 grams per mole for hydrogen plus 6 times 15.999 grams per mole for oxygen. So that gives us a total of 180.155 grams per mole. A couple more molecules or compounds that we can calculate the molar mass. Ammonium hydroxide. This is a good example. It shows you how often, because this is ammonium polyatomic ion and hydroxide polyatomic ion, it makes sense to sort of split up. We don't always show all of the elements together. So there are 5 hydrogens here, so just make sure you add them all up. You can add 4 hydrogens plus 1 hydrogen, however you want to do it. But you want to make sure that you have them. So the molar mass for ammonium hydroxide would be 14.007 grams per mole for nitrogen, plus 5, we'll add them all up at the same time, 5 times 1.00794 grams per mole for hydrogen, plus 15.999 grams per mole for the oxygen, and that gives us a total of 35.046 grams per mole, and that's the molar mass for ammonium hydroxide. Now here is a hydrated compound. Remember that hydrated compounds have several waters of hydration, and each one is specific to the compound. And when you're calculating the formula weight for these compounds, you have to include all 7 waters of hydration. Okay, so let's do that. So magnesium is 24.305 grams per mole plus 32.065 grams per mole for sulfur, plus 4 times 15.999 grams per mole for oxygen, plus, now you can do this any way that you want. You can add up the molar mass of water and then multiply that by 7, or you can distribute the 7 into each of those. It doesn't matter how you do it, you just need to make sure you add up all that individual mass. So I'll just do it straightforward. There's 14 additional hydrogen, so that's 1.00794 grams per mole, plus 7 more oxygens, 15.994 grams per mole. And so throw that in your calculator, and that gives us a mass of 246.470 grams per mole. Just like we did for copper and carbon, you can calculate the number of moles of a substance for a molecule or compound if you know its molar mass. So I already calculated the molar mass of these two compounds. So if we have a mass of, say, 55.05 grams of magnesium hydroxide, we can determine how many moles that coincides with. Okay, so what we can do is just multiply that by the conversion factor. So we know that in 1 mole of magnesium hydroxide, there are 58.319 grams of magnesium hydroxide. So those would cancel out, and it gives us moles, and it turns out there are 0.9439 moles of magnesium hydroxide. Okay. What about 17.9 milligrams of glucose? Well, we know that the molar mass we just calculated is in grams per mole, so we are going to have to convert milligrams to grams first, so that we can use that conversion factor properly. So 17.9 milligrams of glucose times 1 in 1 gram, there's 10 to the 3rd milligrams. And we already know that in 1 mole of glucose, there are 180.155 grams of glucose. So grams are going to cancel out, milligrams are going to cancel out, leaving us with moles of glucose. And this turns out to give us a number of 9.94 times 10 to the minus 5th moles of glucose. Okay, so if we know the number of molecules of a substance, we can use those same conversion factors to give us an idea of how many grams that number of molecules would give us. Okay, just again using our conversion factors for molar mass, and again we might need Avogadro's number, which was 6.022 times 10 to the 23rd. And because it's a collection term, we know that we don't always have to be atoms, it could be molecules. Okay. Now ammonium hydroxide is an ionic compound, so really we should say that it is formula units, but it's definitely particles. Okay, so if we have 4.78 times 10 to the 24th molecules of ammonium hydroxide, we know that in 1 mole of ammonium hydroxide, there are 6.022 times 10 to the 23rd particles. So those will cancel out. And then we just calculated the molar mass, and we know that in 1 mole of ammonium hydroxide, we've got 35.046 grams. And so, moles are going to cancel out. That's going to give us a mass of 278 grams of ammonium hydroxide.